Hi, and welcome to the next lesson in Invading the Future. So, MVP 1 was successful. We used our risk-based angle of attack, we communicated well between our knowledgeable decision makers, and we progressed an iterative approach, and we came out the other side and we proved at least desirable and feasible. And now we're going to have to wait in the marketplace and check and work in the marketplace to see the leading and lagging indicators about viable. But we'll get to a bit more detail on that a bit later. But as we've done MVP 1, we spoke about what we probably need to go and tackle in MVP 2. So, if we were engaged in this battle of achieving MVP 1, are we fully set up and prepared now to go and tackle MVP 2? How do we increase organizational capability and memory? And are the same people going to do MVP 2 that did MVP 1? You know, we'd really hope so, but we cannot always be entirely sure. There may be different people involved. And how can we ensure that we are still going to be able to do good next invasions? Because MVP 2 is based upon MVP 1. It is mostly not something that is entirely new, because we're building these platforms. These platforms don't disappear. They stay. Facebook, almost 2 billion people on this platform. You don't replace that platform, you incrementally improve it. And to do that, you need organizational memory and knowledge that builds up over time. So military strategy and tactics, what can we think of in terms of how to do this? Where in the process we've discussed up to now are we actually building up organizational memory so that we can undertake future invasions successfully? Is it when we're doing these features, when we're writing these statements of intent, are we going to use this as organizational memory? No, not at all. This is not where organizational memory is created. The intent of specifying these features, these intents for missions, is to successfully complete the mission. It's to successfully complete the iteration. That is what it is all about. Remember simplicity? We don't want to try and do multiple things with one tool at the same time. It's inefficient. So these just-in-time statements of intent, requirements, if you will, are about being able to successfully invade this future. It's not about specifying organizational memory. So where do we build organizational memory then? Well, in these 2-week iterations, there is the agree of what we're going to do a bit of design, build whatever it is, develop it is, solve whatever problems we want to go and solve, and then verify. So every 2 weeks, we verify that we have achieved this portion of our invasion plan successfully. And this verification is exactly where we build up organizational memory. It's one of the key components of building up organizational memory. So let's see how that works. So as we're choosing in our feature backlog, our risk-based feature backlog, the exact features we're going to tackle in the next 2 weeks, as we're doing them and as we're completing them, for each feature that we undertake, we create a test case. Okay, so we're saying, this is the mission that we undertook, and this is how we needed to build the platform at this point in time. And as we're building it and completing it, we're creating a test case to say, this is how our platform must behave. Okay, so this is how our platform must behave. And as we complete the next sub-feature, we create another test case to say, we've added to our platform, and now we're going to test that our platform is still behaving in the way that is desired. So this is both in terms of previous capability that has been created, that is still working, and also each time as we add new capability, that this new capability on the platform is still working as expected. And this just continues as we progress through this invasion plan. So we're basically turning these statements of intent for improving our platform into test cases, so that by the time we come out the other side, we have a bank of test cases that specify clearly how our platform must behave. And now we're setting ourselves up well for an MVP 2 because we'll be able to move fast. We know how our platform must behave. Now, something one can ask is how should this testing be done, this verification of our platform behavior? Should it be done manually? So do we write a whole bunch of statements saying if this is clicked, then this must happen, and then this must be clicked, and this must happen if these values are above or below or certain, whatever case may be, then this is what must happen. Now, of course, that is possible, but one can also do automated tests. And that is building the capability to be able to automatically test your platform that it is still behaving in a way that is required. Now, how should we think about this? There are many organizations that are still going, automated testing, really? Is that necessary? And I'm surprised and shocked still by the sort of amount of discussions about and the slow progress in moving to this automated testing approach. Why is it so critical, especially now? Well, let's look at this. This is a car driving itself. There are quite a number of scenarios involved. I'm sure you can imagine. We're stopping at traffic lights. There are cars going all over the place. Pedestrians, roads may change, dogs running across the road, all kinds of things happening. Maybe someone else making a mistake in another car. How do we know all the situations that which may occur? And not only that, how can we quickly simulate and verify that our car driving algorithm is behaving in the way that it is supposed to behave? How are we going to do this? Not only that, in the sort of old days, we specified our programs. We typed out basically a recipe that the computer must repeat. And if the computer behaves, the program behaves in a way that is not suitable to us, we could open up the code and we could go and look for the bug. And by looking at it, we can fix the bug. Nowadays, with machine learning, artificial intelligence, there is no specific code. It's just millions of numbers being neurons. And these neurons act together to behave in a way that is desired by us. We have these artificial brains that behave in a way that is desired by us. There is no code. There is no code. There's nothing. It is like a human that has a brain that can't play chess. Then the human learns to play chess. What specifically has now changed about this brain? We don't really know. It's just formed millions upon millions of new connections, and these new connections are the embodiment of how you play chess. And this is what our machines are doing these days. We're giving them these problems, and our machines are learning how to solve these problems. But there's no code. It's just billions and billions of numbers that specify neuronal behavior, and it can solve these problems. So our automated tests are really our only safety net as we're automating the world. And we can, as we're putting more artificial intelligence or machine learning or artificial brains into our platforms, behavior is the only way that we can make sure that our automated world is still behaving in a way that we want it to behave. So imagine you get into your Tesla car and there's a couple of people doing manual tests. So Tesla is probably having the largest distributed computing platform. And what I mean by that is the platform is distributed and actually is moving. Cars are pretty much becoming laptops on wheels. So computers on wheels, and they're starting to drive themselves, and they know where they're going and what they're doing. But this is based upon artificial brains, these neurons that learn how to drive. And these cars are becoming part of this transport platform. And code, new behavior is released to these cars. So we will pretty soon have millions of cars that received software updates about how to deal with different situations and different capability. And if you have a car and you know that it was tested manually, only for 420 different scenarios, because that's all the company could afford to pay 420 people to test these scenarios, that is not a great thought, is it? No, you wouldn't want to get into your car and have it take you anywhere. You would want to rather, the organization, the company that's producing the cars, to have been able to run millions upon millions upon millions of tests within just a number of days to make sure that these cars are still behaving in the way they're supposed to behave in a very complex world. So as we're moving to automating global production, distribution, and service, and using artificial brains inside these various platforms, this global production, distribution, and service platform, we have no choice but to move to automated testing to make sure that our production, distribution, and service platform is still behaving in the way it is supposed to behave. And that applies whether you're part of the finance and coordination platform in the insurance and finance and banking industries, whether you're part of the transport platform, the energy platform. All of these platforms will be updated and changed frequently, and we need to be sure that their behavior is how we need it to be. And for that, we need more and more automated testing. Otherwise, we won't survive, literally. So, as we progress through these iterations, what we do in every iteration is we're going to be creating code, but we may also create additional artificial brains that are able to exhibit in the behavior that we are requiring. And as we do that, we write tests. And so another aspect of creating organizational memory is if we write code, how we write this code. So code must be written in a way that it is easy to understand and easy to change. It must be written for the next human that is going to be interacting with that code. If you don't invest in that, bad news, not being able to adapt to the future very well at all, not being able to adapt your platform to reality very well at all. And so we progress incrementally through our feature backlog, our MVP, and creating these automated and some manual tests, but more and more automated tests to be able to cover all the different kinds of scenarios and being able to properly verify our platform behavior. As we're coming towards the end, we can then create additional content because we've now figured out how to do this. It's become a recipe. So by the end of it, we can say, this is how we built this thing. We can create these user manuals about how this thing works. We can create processor architecture, documentation, artifacts, because the uncertainty has now been removed. And now we can capture this certainty so that others can come after us and adapt the platform based upon this knowledge we created of how this platform works. We've solved all of these different difficult and complex problems. So the only kind of organizational memory we really create as we're progressing through this feature backlog are the automated tests. And once we've really sorted out the uncertainty, towards the end we give ourselves time to now capture the recipe aspects of what we've done. This is how it works, and this is how we did it, and this is how it must be done. And you can use videos or blogs or wikis or whatever way you want to go about doing this. Not only that, we also create organizational memory by how we work. So we said that we only specify intent at whatever level is required. And the team that is going to deliver on that intent for us collaborate and work together very closely. We had these workshops where we all built an invasion plan on a wall that is exchanging information between all of us. So there's an inordinate amount of instilling knowledge about our business, knowledge about our solutions, knowledge about how to solve problems in our workforce, in our knowledge workforce, our future invaders. And it's a critical aspect of how we work is investing in solving complex problems together and coordinating to solve complex problems together. Another critical portion of creating organizational memory. So this is the critical aspect of competitive advantage in the future is how quickly can you adapt your platform? How quickly can you understand how customers are using your platform, how they might want to use it in the future, how to change your platform using both manual coding or engineering, as well as artificial brains that learn new behaviors, and how quickly can you verify that the existing platform capability is still working and that the new platform capability is precisely what was needed, and be able to test that and maybe place the new software into a couple of cars, closely monitor those cars to make sure they're driving properly, and then roll it out to all the additional cars. And if something would go wrong, how can you quickly revert to the previous version of whatever that software was, so that your platform can continue servicing us and being part of our global production, distribution, and service engine. So critical aspect of competitive advantage is organizational memory and being able to verify that platforms are still behaving the way that they're supposed to behave. So in terms of military strategy and tactics, aspects again of simplicity. So we use things what they're supposed to be used for, and not trying to do many different things. In the old days, we used to write sort of, requirements, and those requirements were expected to be organizational memory. But this doesn't make sense because we're still fighting with all these complex problems which we're not sure that we're going to be able to solve in a certain way. So when we write these requirements, when we specify these intent, these features on an incremental basis, the only reason we're doing them is so that we can fight these battles successfully and complete the invasion as quickly as possible. Okay, so we keep it simple. We create tests, and the tests are about verifying behavior and capability. Logistics, setting ourselves up to be able to do this. The environments, how many environments do you have available to verify the behavior of your platform? Imagine a company such as Tesla that is releasing new software into an existing transport platform, their cars. And how quickly are they able, and how well are they set up in terms of environment to simulate millions upon millions upon millions of different scenarios and run through them quickly? How well are they set up in terms of the server capacity and whatever else is necessary to be able to do this efficiently? Well, force protection. Force protection are these test cases. We can work fast. We can adapt our platform fast because we have these test cases that are helping us determine whether the platform is still behaving in the way that it is supposed to be behaving. And also, when we roll the platform out, if there should be some problem, it is possible for us to instantaneously roll back this version of the platform to a previous safe version. So our invaders of our futures, our teams, they can move fast because we have good force protection that the platform is still working. We are verifying what we're doing every 2 weeks, and we can adapt quickly based upon what we are learning. And if we should have a problem taking something live into our platforms, we can roll it back quickly. So critical to set this up. Fires, it is your ability to do this. What are your skills in your organization to be able to do testing and automate the testing? How good are you at being able to distribute and share knowledge amongst your knowledge workers? How good are you able at doing that? In terms of coding, how good are you at writing code that is easy to understand and easy to change? In terms of engineering, how good are you at using, if you're in the physical engineering world, a modeling software? Can you build an entire physical product and do physical modeling of that solution or the production line or whatever the case may be? How good are you able to use 3D printing as part of your prototyping process? All of these technologies and your ability to use them to verify your incremental invasion of the future, as well as creating this organizational memory to make sure that your platform is still acting like it is supposed to. And of course, this gives you great maneuverability. We can move left, move right, because we have our force protection in place, our automated testing and manual testing capability in place and sorted out. We've got the environments, the logistics, the ability to roll forward, backwards, and this gives us great confidence to invade futures faster than the competition. Thank you, and look forward to the next lesson with you.